This conference will now be recorded.
So, good day, everyone. Thanks for joining in the call. The agenda for today is to get through the Immersion Standards and Best Practices document as far as we have finalized that with a smaller work group setting. We believe that all the content is there. 1 week ago, we had the last interaction around this, and we identified a few small items that we wanted to get a final discussion on. These are minor details. So what I would like to do is to go through this document in the status where it is now, and discuss a final approval for the next meeting in 2 weeks. Where we can present this as a final document. So anything that comes up today can still be processed in the next 2 weeks. But the aim for this document is to move towards completion in the next 2 weeks. Is there anyone on this call who was not part of the last two review sessions? Okay, no response. So I guess everybody is familiar with what is in this document now. I'll briefly run through the contents. All the details have been discussed in quite extensively. So the first chapter relates to the definitions of the different immersion technologies. So we differentiate between single and dual phase, enclosed chassis, open bath systems, and hybrids, which are crossovers between different types of technologies. There's currently a minor discussion going on the term open bath. A reference has been made that different terms are being applied to an immersion system, to tank-style immersion systems, and the terminology used for that. Clarification is being sought on this. If anyone has knowledge or inputs that can help put this discussion to rest, that will be very welcome. Basically, the question is open bath the correct terminology for tank-style immersion systems, considering the fact that they often have a lid, sometimes may be sealed? Is there anyone who would like to provide some educated feedback on this? Then please feel free to do so.
I think that's a good point. I mean, is it okay if you just say bath or tub and leave the open off? Does that still define it well enough, you think?
Well, we could, yeah, it could be. It goes into the dimension where I think there is already a terminology that is being applied in the industry, and I think the most important concern here is that we follow the terminology that is predominantly present. So I'm personally used to the term open bath as a description for pretty much anything that is a shared container with vertical, where you put servers in a vertical direction, as opposed to the horizontal rack style chassis. What's in the name? So is there another term that's being applied, or is there a requirement to further specify whether it's open or sealed? I don't think there is any open bath solution, which does not contain a lid. They all contain lids. From a technical point of view. Okay, so the
Yeah,
current status of this topic is that we've requested feedback from Dr. John Summers, who is a lecturer at the University of Leeds. Most of you will probably be familiar with him. I've asked him to, because he's been using references like this for a decade already, I believe, or at least close to a decade. So I've asked him to take a decision on this. He has not responded with anything yet, so I'll be looking forward to a response. Was there somebody who wanted to add to this?
well, I just want to say don't rely too much on maybe what's been used for a decade by maybe a small group of people, because this paper is potentially exposing this to a much broader audience, so there's no real history behind it. So there could be just a legacy term that happened for some reason, and if the word open makes people think that of course it doesn't have a lid because it's open, then maybe that's the wrong word, even if it's been used in the past. So just something to consider.
It's a fair point, and I do tend to agree with that.
Yeah, I tend to agree with what I think Rob said as well. We shouldn't just refer on what references have been adopted by a minority. I think we should look at parallels with where and how the flows of this format could be considered. For example, my personal choice, I like wine, so how about vat cooling, open vats, or just vats is an option. But yeah, I think there could be some really good reference points in it that could be used. And as Rob says, to Rob's point, once this document gets publicized, it's going to have a very broad audience, so it will be something that will stick within the target audience for a long time.
Yeah, I concur with that, Nigel. I do agree with you as well. Tank is something that has been used a lot as well.
Yeah, Tank has been used. Tank and Bath seem to be the ones that have the most references available.
All right, I'll take this suggestion. Take these suggestions.
Perhaps a survey monkey amongst the members of this sub could be initiated, and then we could select the best ones from there.
You're saying a survey monkey?
Yeah, just an online survey with some nominated names, and you just do a polling of what ones should be the reference point. That way you can get a consensus from the larger group.
Sounds interesting. Do you have any experience with setting it up?
Yeah, sure. I can help to set that up. No problem at all.
All right, great. So let's do that. We'll be in touch by email, and I assume that's something that goes outside this call then.
Outside this call, but to the audience that's within or open to the subcommittee, they can then go and say, look, we're considering some naming conventions, and we can say to a couple of them, and we can say, please poll your favorite ideas out of X, Y, and Z, and then we can everyone will have input, and we can then review the consensus from the audience.
Perfect. I like the idea, so we'll do that. What about the enclosed chassis stamp? Nigel, you're personally involved with an enclosed chassis approach, so is that the terminology that you would prefer?
Yeah, I'm pretty close with that. So I'm quite comfortable with enclosed chassis. Certainly am, especially because my background is also in server IT equipment, and we often refer back to chassis, server chassis.
I've heard the term clamshell quite a lot as well.
Yeah, clamshell can be utilized as well, but clamshell deals with the sealing mechanism and method. So I think it's quite limiting in its use.
Okay.
Clamshell also used parallel in mobile computing, where we referred to a notebook being a clamshell notebook as well.
Right. Okay. So we'll stick to enclosed chassis then. All right. Cool. Anyone who has not done the homework and read through the documents, I'm not going into all the details at this level, just that elements that were specifically marked to discuss in detail. So feel free, it is available online. You can make edits, you can add comments still. So by all means, go ahead and do this. So the next chapter is regarding quality and safety requirements. Basically a list of requirements that every technology should be able to adhere to. It's generic. Everything in this document is completely agnostic to the type of technology that it's referring to. So first of all, the certification markings. It might become, you might consider this, so some people might consider this something new, but every region in the world has requirements for certifications. European Union requires CE certification, the United States requires UL certification or FCC markings, depending on the type of solutions that you apply. The only, currently the only ones that are specifically mentioned are the European Union and the United States. And for the rest, it's simply a reference to a Wikipedia document. The mechanical safety requirements are basically...
just one point that, sorry to interrupt your flow. Just on the certification, I mean, the only other large geography would be China, China or Asia. Don't know if you'd want to include them as part of their the bigger group as well, because they have their own certification.
Sure.
As well.
Do you know which specific certification covers the largest region? Because that's something I stumbled upon, that there are quite a few, and they depend on the type of technology you want to. If it contains something electric, there is a completely different type of requirement than something that's dealing with liquid. So it seemed to become fairly complicated.
As it always is. Let me see if there is an obvious one. I'll speak with one of my team members that has a specialism in this area and see if we can get that concluded.
This is the Wikipedia page that I just put on the screen with all the certification, the regional certification standards, and there's quite a few, and this is not even complete. And the compulsory certificate mark is one, and I believe that there was some
CCC, but then it'll be different depending on what type of product it is. Like there's CEMC, which is for electromagnetic compatibility.
There you go. So at least UL, FCC, and CE were quite generic in nature. You just need to have either one of these markings if you want to sell something in the States. That's what I understood. CE, if you want to sell anything commercially in Europe, you need CE. It doesn't matter what it is. It doesn't matter what the purpose is. You just need the CE stamp if you want to trade in Europe.
Yeah, and after Brexit, we'll have our own UK standard as well.
Yeah, you'll make sure to invent something. Yeah.
Fair enough. Good point.
Good luck, by the way. Clock's ticking. Mechanical safety requirements for any immersion technology. That covers basically a lot of safety elements. Very common sense, very basic. But some of these elements do make the difference between a student project or a serious data center application. So it's just common sense. We're all dealing with liquids. Every liquid technology deals with liquids, especially immersion. We're talking about dielectric liquids. That's by definition chemical in nature. Therefore, safety requirements need to be put in place, or safety measures should need to be put in place. It doesn't matter how dangerous or how not dangerous something is. It's just industry standards. Now, here we come to the next marked elements. That's the introduction to liquid management. We're making a reference here to a division in liquid types. We've been struggling a bit with this because the tendency inside the industry was to refer to oil or chemical liquids. The reference is being made to 3M liquids as oils, which is I think not true, but I'm not a chemist. As far as I know, that's not true. So last week we ended with, let's call it oil-based chemicals and fully chemically engineered liquids. We've done some more homework on this, and it seems that it might be as simple as just differentiating between hydrocarbons and fluorocarbons. Nigel, you're used to working with these liquids a lot. Would you agree with this division?
Yeah, I'm really happy with hydrocarbons and fluorocarbons as being the two generic terms that we use, definitely.
All right, perfect. Mustafa, you had some opinions about this last week in the work group. Do you want to add? Do you have any input on this?
No, I think it's okay.
All right, cool. And I've solved the issues on ease of understanding by just describing the liquids between brackets after the terminology. So these terms will only come back at one point in the document. There we go, none. So if nobody objects, then from now on, this should be the standard, I guess.
Yeah.
Rolf, I like what you did in parentheses, but you might want to put IE in front of fully engineered liquids as well. I'm not sure if there's any non-fully engineered fluorocarbon solutions.
That's a good question. Are there any non-fully engineered fluorocarbons? Nigel, are you aware of that?
No, I'm not aware of that.
From what I understood from one of my colleagues has a chemistry background, and he mentioned what he's been teaching me is that fluorocarbons are essentially fairly difficult to create.
That's what I would
very complicated. So
yeah, I would just simplify it to call it engineered fluids rather than fully engineered fluids. Just an engineered fluid.
Yeah, you get a bit of a conflict there with with a brand that actually engineers oils, which are hydrocarbons again. There's an industry thing. But I had the original phrase here was chemically engineered liquids, but that would also cover oil, simply because oil is also a chemical. Dale, do you have anything more specific then? Or do you suggest IE engineered liquids?
Well, yeah, I just recommended adding IE like you had in the last one. Just use it as an example. I think it really is helpful to have an example, but that way if you just say engineered fluids, you're almost defining a new term.
Yeah. All right, cool. Very good. So here within the chapter, within the paragraph about liquid management, it refers mostly to containment measures that immersion technology, the use of dielectric liquids should only occur in well-ventilated rooms. Doesn't matter whether you're talking about hydrocarbons or fluorocarbons. It's the prescription or it's the designated. It's the way to deal with chemicals in accordance with the safety sheets and the technical data sheets that are provided by every liquid manufacturer. Okay, so the next chapter is focused on management and monitoring of liquid technologies. So what we've done there is define a basis, the minimum standards that a thermal monitoring of dielectric liquid should happen in any type of solution on two locations, whether it's somewhere around input or output. That a warning system should be in place in case of overheating, so that at least a warning can be sent out, and operational status of an integrated or CDU pump status, and there are several classifications for optimized type solutions, so to allow differentiation between, or at least different marketing approach for different types of technologies. And the two that we've identified now is thermal optimized requirements. Some technologies are specifically good at thermal management. Some solutions are specifically aimed at high safety use for high availability systems. If there are any other unique aspects that could be described in such a way that can help in positioning certain types of technologies for certain types of platforms or implementations, feel free to bring them up. I think this is a part of the document that should remain open towards the future, and where different types of classifications can be put in.
Hey, Rolf, I have a concern regarding the remote control. It seems like that doesn't need to be a requirement in an open spec. I mean, we're looking for interoperability, and some owner-operators would rather not have remote control because of some, security issues as well. And in any event, it just seems to me that I'm not clear why that's being entered as a requirement. There's a number of places where it says remote control.
Which lines and which paragraph are you referring to? Is that the high safety systems alone, or also others?
No, I just spotted it now, and then the one right below that as well, remote power control of all electrical inputs. I mean, I guess it depends on how you're defining remote.
It's the point that if you're managing an environment remotely without having any people in front of it, and you get the warning that something is about to blow up, that you can stop the process. Right. Just as you can kill the power to a PDU in most data centers.
Right. So in essence, it would be off-site remote control.
Could be.
Yeah. There are concerns about, somebody taking those controls over and causing havoc in the data center in certain secure situations, but.
Yeah, I see what you mean. Let's see. Remote power. So the line of reasoning here was, if there is an issue, let's say a fire or an overheating scenario where it becomes less safe to operate the liquids, you need to be able to shut off the power inputs. Whether you do that with a switch somewhere else in the room, or you require digital access, I guess we could be agnostic to that.
You'd have an emergency power off switch if in case of fire or emergency. That's usually a hard switch. I see Dale's concern around remote
Yeah.
capabilities, but those are set at server level as well. So the servers also have their remote power boots on and diagnostics that you can run. Whether you want to put it in, it's part of whether it's part of integration within the system is a question mark. And as to Dale's statement, it depends on the application set, whether the customer the end user is comfortable having remote logins. But you do need some sort of admin control on it in any case, because you don't want to go to each single rack to try and manage, or each single row to try and manage the system.
That's some good points. Good points. I'm just checking. It's only the remote power control and remote pump control, right? There's no others in here, defined in here. Multiple decisions, automatic safety mechanisms.
Could change it to admin pump control. Maybe the word remote is what's causing the subjective nature of the point. And
Yeah.
If you had admin control, that would be quite acceptable.
Are you satisfied with that, Bill?
Yes.
Okay. So, well spotted in that case. So we get to the data center infrastructure management, which in this case refers to Redfish. And this is a definition supplied by one of my colleagues. And for me, this is not my expertise. And so far, I had to conclude that none of the people that have been dialing into these calls have any idea on about the Redfish definitions. So far, it seems that I believe somebody did do some checking up with some software engineers on the validity of this, and I've had no revisions or revision requests. So, is there anyone on the call here that is familiar with Redfish input and whether this would be applicable?
Yeah, I only have slight experience with it. As we did some facility equipment suggestions through the DMTF. So has anybody from the DMTF organization been involved? Because this can get submitted, and then they might be able to add this to the schema.
There was a presentation from one of the, I don't remember who it was. I need to look it up.
Probably John Leung from Intel or something like that, maybe.
No. Redfish, it was one of the specialists from Redfish side.
Do you think it might be Jeff Otter from HP?
No, it was not HP.
It'll be on one of the recordings, Rolf, from early last year. That was referred to on that side. But to Rob's point, I think he's talking about it's DMTF who's open standards offering for this formatting. So I'm happy to have a look at that and just see if there's anything that jumps out, and reach out to the teams on both camps and just go and review those previous recordings just to see if something jumps out.
John Haas. It was.
John Haas. There you go.
Yeah, absolutely.
Would you like me
to, he helped us out with the facility stuff. That's the guy. Yep.
You want me to take that one, Rolf?
Sorry, what is it? Can you repeat that?
Do you want me to take that one and go offline and work on that one with them?
Yeah, if you're volunteering to do that, feel free. Yeah, please. Great stuff.
Yep. Yep.
Let's try and get this all finished in 2 weeks. That would be great. Then we have the first spec in order. So I'll skip that for now then. Thanks for picking it up, Nigel. So the general standards, which is more which is very general in nature. First of all, starts off with comparison metrics and the definition that we're going to use the International System of Units, which is in accordance also with the cold plate workstream. And also the biggest coverage around the world. We had a discussion last week on all the metrics that we could or could not apply because liters are not officially part of the SI system, and several others as well, which made our lives a little bit more complicated because there are other industries that need to be involved with liquid infrastructures like pump suppliers. And they are used to working with liters or gallons and the type of metrics, but every supplier around the world, almost every pump specification that you can find has a reference to liters per minute or per second or cubic meters per minute or per hour. So I decided to rephrase it again in accordance with the Wikipedia page around the SI system, and use the phrase all used metrics are based on the International System of Units. Wherever required or commonly accepted, metric prefix may be applied to ensure workable number formats. I think that goes beyond saying, but still. And by basing it on the system of units, the International System of Units, we can allow some non-standard but accepted metrics to apply as well. So there is in the bottom, let me just quickly go to that page. And the phrase mentioned here is, let's see, yeah, non-SI units accepted for use with the SI. And that also includes liters. So I think that should probably cover the use of overlapping industry standards and allow that to take place wherever that might be required. Is there anyone who would disagree with this or would have additional input on this? Nobody. That's great.
Yeah, keep it metric.
And we'll put this to bed as well, and we'll be a little bit flexible on the SI. Good. Okay. Now we get to the slightly more exciting stuff, and that is focused on how can you compare fundamental different immersion style technologies with each other. There's one addition in here that so something that we were trying to achieve is to come up with some elements, some comparable metrics that we can apply as some sort of industry standard so that end users can more easily start comparing different technologies. There's a lot of ways of comparing technology, just scrolling it over the screen with the things that we come up with. So some of these are marked with an asterisk, which could indicate a standards for everyone to comply with, or to at least mention in some sort of a spec or in marketing or whatever way deemed necessary. And the main differentiators are rack type and solution type, obviously. The liquid category, which may or may not be relevant. Liquid type may or may not be relevant. But the consensus is that all these type of information should be made available if a customer asks for it. So these are common questions that a customer might find relevant and request, whereas the asterisk marked elements might want to consider using those in the public domain. Perhaps compliancy. This one is maybe not was not meant to be an asterisk, I believe. But density, to get away from the discussions like, well, I have a solution, I have a rack that can do 500 kilowatts, but it is a 10-meter long rack. That doesn't add any comparable information to any discussion. So the definitions that are now are based on compute density, solution density, and solution footprint as main differentiators, which in essence are the maximum allowable or possible kilowattage that a solution can handle in the space where the compute is located. For an immersion system, that will be the tank itself. For an enclosed chassis system, that will be the footprint, the physical footprint of that rack. Whereas a solution density should also include the surface area that is covered by, let's say, the front door or the rear door or any other fixed elements that are part of that solution. So if there is a CDU in place, that will always take up a surface area. And calculating that back to the square meters means you can allow for the most optimal deployment style, but it should include everything that takes up floor space. Whereas the solution footprint also includes the free area where nothing can be installed simply because you need that space to access the solution, or you need some airflow somewhere for some reason, or a piece of infrastructure might need to be put in place, and that needs to be covered in the solution footprint. So you get from the highest number to a much lower number towards solution footprints when you're talking about kilowatts per square meter. And then as an additional layer, we've decided to add the ASHRAE standards, the ASHRAE temperatures, where the W5 is actually anything above 45 degrees Celsius. I've decided to just use a single temperature there. But as a standard, something that everybody should start preparing is a maximum energy loading based on the W2 cooling supply, which is 27 degrees Celsius, which we believe is a temperature that most, if not all, the immersion style technologies in the market today should be able to work with. And for the rest, it's all about coming up with comparable standards, everything calculated back to square meters or meters or...
Hey, Rolf?
Yes.
Rolf, on that topic, I mean, it's desirable, it seems to me, as a trend to move towards warmer and warmer temperatures. Why did you pick 27 rather than one of the warmer temperatures?
Because I want to make sure that we're agnostic. So if there is an immersion technology that is less tolerant to heat with certain densities, or that is specifically designed to deal with twice as many kilowatts, I don't want to force everyone into the highest temperatures. There might be very viable, very good immersion solutions out there, which simply work much better at 27 degrees Celsius. as long as that's I don't mind going for 40 degrees Celsius. I don't mind going 32 or 45. I don't think it's. I don't want to take the position to tell data centers that, or tell liquid technology. I don't want to decide for every technology out there that they need to be tolerant for 45 degrees Celsius or 32. It's just to be agnostic as possible, making sure that every technology can come up with a figure that makes sense. So this figure is only for comparison. It's not as it's not meant to show that half of the industry may not be able to achieve it. And besides, realistically, most of the deployments that are out there are not really working with the warmest water yet. So that's basically the reasoning. That's the explanation. I'm happy to take W3 as a standard. I think I would object to W4 because I know for a fact that there's a lot of technologies who cannot deal with 45 degrees. At 32 or 27, I don't think there's a major difference. Is there anyone else except Dill who also has a strong opinion about this? Do others? Is there a more common feeling that this standard should be focused on 32 degrees Celsius? Because all I'd have to do is put down my finger now, and it becomes a number 3.
My view, Rolf, is very simply that it depends on. It's very subjective to the application, as well as the ITE that's within the servers, and the footprint that the facilities within. So I think to set it at a specific level above that, I think a minimum should be W2. But I think to set it as a standard, anything higher than that could be open to scrutiny.
Yeah. This is also subject to the infrastructure, so it depends on the heat rejection system. It's not only on the IT.
This, guys, this is not a standard that something needs to be complied with. This is a context for a compute density. So the figures, compute density, solution density, and solution footprints are based on whatever temperature you want. So if you want to position a 50 kilowatts solution based on 12 degrees Celsius, feel free to do so. But it is not comparable with somebody else's solution who can do 20 kilowatts with 40 degrees Celsius, because those two implementations are not comparable. The only purpose for this row here is to describe that these density figures, a customer might decide to use one of these temperatures, W1 to 5, for selecting or for comparing different technologies, whereas one metric should be universally available for all these compute densities. So isotope should be able to position the compute density, solution density, and solution footprint figures based on 27 degrees Celsius, and so would Asperitas, and then both figures suddenly become comparable as a maximum. Then it says something about the technology or the application, and whether that is tolerance for 45 degrees or maximum tolerance for 32 degrees. It doesn't matter so much, because then suddenly it describes something comparable between the two. So this is not to state that every technology needs to be able to work with 27 degrees or 32 or 45.
I don't want to get wrapped around the axle on this particular point too much, Rolf, and extend the call unnecessarily. But I'm not familiar with the ASHRAE W1 to 5 being referred to as density. I'm used to them referring that to as the fluid circuit for the primary, the temperature of the primary circuit within the facility.
Exactly. No, but that's precisely the point. So if you do a deployment in a facility where the water supply is 32 degrees Celsius, and you're going to calculate your maximum energy load based in one of the isotope racks based on that temperature, you can come up with some kind of a figure, right?
Yeah, I'm with you.
So can I with my technology. And therefore, we can both come up with a comparable metric that allows us to compare both our technologies with each other with the same data. Whereas on my website, I might position that I can do a 50 kilowatts mini tank, but have some small letters mentioning that is only valid when I cool it with minus or with 5 degrees Celsius. Which means I can't do that. I will never be able to reach that number if I supply it with 32 degrees Celsius. So then I create a disbalance.
Yep, that's fine. That's fine.
Is it understandable?
Yeah.
And does this explain the setting properly? Okay, cool. Now here is one that kept us going for quite some time. We still haven't got something to put in there. This was a suggestion to come up with a power figure per liquid volume. Whereas the goal would be of every metric in this table to make a comparison that is valid across any technology and not specifically relevant for a type of technology. And the power per liquid volume, there seem to be several different reasons for wanting to have a reference to that. One is related to liquid cost. Another motive could be to compare the density of electronics that you can achieve, whereas an immersion system that has some additional capacity with a low value liquids would not give any indication on how close you can put electronics together. So there have been different motives to come up with a power per liquid volume, and to make that a comparable metric. We have not been able to achieve that yet. Is there anyone who has an idea on achieving one of these goals? Or the goal to come up with an electronic density description that is generically applied over any of the technologies? If not, I would like to propose that I remove this this table row altogether.
I like the table row power per liquid volume because it does give you a view of how much fluid you're utilizing to cool a set TDP or a kilowatt of. So I think it certainly will become relevant in the long term.
So what is the relevance in the amount of liquid you need? So if I need 10 liters of water to cool something, and that is in a closed circuit, or you need something, you need only half a liter that might evaporate quite often. How could that become a comparable metric based on a solution? Is that not more a type of metric that you would want in an IT spec, for example?
Well, when you're looking at the fluid volume, you need to consider what is the cost of that fluid and what is its refresh cycle as well for maintenance requirements. And by understanding how effective that cooling solution is, you can have that equation which is relating to the power and volume of fluid that that's available. Now, there obviously needs to be measured up against the cost of the fluid, because if you compare the hydrocarbons to the fluorocarbons, there's a differentiation in the cost, but each of them has their own merits for and characteristics that will support it in terms of its total cost of ownership for the life of the facility. So
and that's where I'm getting a little bit wary, because that means we need to bring up a cost figure in a comparison metric across solutions, and that's something that we've been trying to avoid so far.
Yeah, I agree. We don't want to, because that becomes furthermore subjective. But total kilowatts per cubic per liter of fluid is, I think, a good metric to keep in.
So how would that be relevant for a technology like Asperitos, where we use a commodity type liquid, which is super low cost? We're talking about $2 per liter.
Yeah, well, if we had say four different tub vendors that were obviously proposing a solution, but vendor A had developed a way that was more effective to be able to deal with the cooling and the fluid and minimize the volume of fluid, then that gives them a competitive advantage, which should be within the spec.
I see. No, I understand the relevance when it comes to fluorocarbons. But yeah, that's also exactly why I have an issue with this line, because it's not agnostic to immersion, to the technology style. Why don't we? Shall I give you a call immediately after, because the time's running out. We got 2 minutes left.
No problem.
On the call.
Take it offline.
Shall I give you a call immediately after?
Yeah, that's fine, Rolf. Thank you.
I'd love to hear your thoughts on this, because you seem to have a much better angle on that. So I'm just gonna show what the rest is. Documentation standards is covered. Liquid properties are covered. Please, Nigel, as well, have a look at that table and make sure to identify things that might be off. Required liquid specifications that anyone needs to be able to supply, and some basic data center interface requirements, including material compatibility towards metals that might need interfacing. And that's pretty much it. So if there's anyone with specific knowledge about one of these topics, feel free to send in your comments. Right now, another call needs to start, so we're going to need to end this call. I'm hoping that you'll all be joining in 2 weeks from now.
Thank you, Rolf.
And till 2 weeks from now. Till next time. Thanks all.
Thank you.